our lesson is all about Module 3, which is minerals. So, syempre, sa module na to, we are going to discuss about the definition of minerals, importance of minerals, and physical properties of minerals. So, this module encourages you to be familiar with the common rock-forming minerals using the physical and chemical properties. So there are various activities such as experiments which are provided for you to perform to strengthen your knowledge and skills regarding the topic. Okay, let's start. So minerals is said to be the building blocks of rocks. So we all know that our Earth's crust is composed of many kinds of rocks. So ang crust natin ay binubuo ng napakadaming uri ng iba't ibang rocks, and each of which is an aggregate of one or more minerals. Next, the term mineralogy is used and defined as the study of minerals, and the person who studies minerals is what we call mineralogists. So don't forget the terms mineralogy and mineralogist. So next we have the characteristics of minerals. So a substance must have the following characteristics, or the 5 characteristics, for it to be considered a mineral. And it must be, first one is naturally occurring. So what do we mean by that? So when we say naturally occurring, it exists by nature and without artificial aid. It must be formed by natural processes, meaning a mineral cannot be man-made, manufactured, or created in a laboratory. So, ang mineral ay kusang nagaganap or kusang nabubuo. Next one, we have inorganic. So, when a mineral is chemically inorganic, it means that its chemical composition is without carbon. Or minerals have never been alive and are not made up from plants or animals. So, ang minerals ay hindi binubuo or hindi galing sa mga nabuhay or nabubuhay. Next, we also have the homogeneous solid. Next, definite chemical composition. So, all minerals have a specific chemical composition. So, it is a compound having an orderly internal structure and characteristics, chemical composition, crystal form, and physical properties. That is why mineralogists use different steps in identifying physical and chemical properties of minerals. And lastly, the crystalline structure. So, crystal structure is a description the ordered arrangement of atoms, ions, or molecules in a crystalline material. So, crystalline structure plays an important role in determining the physical properties of a mineral or material, such as band structure and optical transparency. So, what if a specific substance meet only 3 out of 5 characteristics? So, paano kung ang isang substance ay na-meet lang ang 3 o 4 dun sa 5 characteristics? Mineral pa rin ba yun? So, no. That is called mineraloids. So, mineraloids is a naturally occurring mineral-like substance that does not demonstrate crystallinity. So, mineraloids possess chemical composition that vary beyond the generally accepted ranges for specific minerals. So, one best example is the opal. So, it is considered a mineraloid because of its non-crystalline structure. So, ulitin lang natin. So, di ba sabi natin kanina, yung 5 characteristics ng minerals, yun yung batayan para ang isang substance ay masabing siya ay mineral. So, in this case, yung case ni opal, So, hindi siya considered as mineral. So, mineral-like substance lang siya because of the absence of crystalline structure. So, in your module, there's an activity and we will identify the following objects. And in your answer sheets, you will determine what type of minerals are present in each of the presented objects in the table. So, ang ating first picture is pencil. Second one is table salt or salt. Third, we have cell phone or cellular phones. Fourth is car. And number 5 is road. So, ano pong gagawin dito? So, in this activity, so since na-identify na natin yung different objects, all you have to do is to determine kung ano bang minerals ang nilalaman ng bawat objects na yan. So now, let us proceed to the importance of minerals. So why minerals are important? So minerals are important because we use them in everyday life. So the mineral quartz is used in making glass. Graphite is used in making pencil or lead in pencil. Fluoride for toothpaste. Chalcopyrite for coins and wiring. We have rutile and ilmenite for white paint. Talc and muscovite for makeup. And gold, silver, and platinum are used in making jewelry. It is said to be that humans cannot survive without minerals. So actually, we need 16 minerals for us to survive. So some of which are sodium, potassium, calcium, magnesium, copper, and phosphorus. How many minerals are there in the world? So there are over 4,200 different minerals, but only 100 are common. And ones that are more rare includes gold and silver. Now that we have already discussed the importance of minerals, so let us proceed to the properties or physical properties of minerals. So mineralogists identifies minerals based on its chemical and physical properties. So for today, we will talk about the different properties used in identifying minerals. So all minerals have physical properties that can be used to define, describe, and identify them as a unique minerals. So let's start with the luster. So luster refers to the brightness of light reflected from the mineral's surface. It is the manner in which a mineral reflects light. So the main types of luster are metallic and non-metallic, or the glassy or metallic. So when you say glassy, it reflects light like a piece of glass, and metallic, it reflects light like a piece of metal. So we have here the non-metallic minerals. So first we have the adamantine. So in adamantine, it has a brilliant light structure or appearance like diamond. Next we have earthy, that is dull. Next we have silky, or having the sheen of silk. Greasy, having an oily appearance. We also have the resinous, a waxy appearance. Vitreous, appearance of broken glass, and nacreous, appearance of pearl. Second one is the color. So the color of the mineral is often variable, and therefore is often unreliable for mineral identification. So the color of a specific substance may be helpful and worse, but not clearly understandable because color may change depending on the surface. third one is the streak. So streak is the color of pulverized powder of a mineral. So the color of the mineral may vary, but streak is generally constant. So the color of powder produced when mineral is rubbed against an unglazed porcelain plate or other fine-grained, hard, abrasive surface. So the color could be different from the crystal's color and is always distinctive. Fourth one is hardness. So it is the scratchability of a mineral or a mineral's durability. So it uses the Mohs hardness scale with a rating system of 1 to 10. So 1 as very soft and 10 as the hardest substance known to man. So the streak plate used in identifying minerals has the 7 hardness of scale. We have here a sample in identifying the hardness of the following items. So ang una, here are the Mohs hardness scale. So first is talc, or the softest mineral is talc. 2 is gypsum. 3 calcite. 4 fluorite. 5 apatite. 6 orthoclase. Quartz for number 7. Topaz or beryl for number 8. Corundum for 9. And number 10 as the hardest mineral is for diamond. So we have here the different items with corresponding hardness scale, katumbas ng fingernails, ang gypsum at calcite. Second, copper coin na may katumbas na 3.5. Third is steel knife or kutsilyo ng apatite at orthoclase naman ang katumbas niya. We have also glass with 5 to 5.5 scale. And last, streak plate na may 6.5 hanggang 7 scale of hardness. So number 5 is the mineral cleavage or cleavage. So it is the ability of a mineral to break when struck along plate. So we have here different samples of minerals with numbers of cleavage. So cleavage in one direction is an example of muscovite. So in feldspar naman, cleavage in 2 direction, and in 3 direction we have halite and also calcite with cleavage in 2 direction. So we also have minerals with no cleavage. Example is quartz. So, ang tawag natin dito is fracture. So, kapag walang cleavage ang isang mineral, ang tawag is fracture. So, mineral can have one plane of cleavage just like the biotite. Ayan ang sample natin. Third, minerals can have multiple planes of cleavage just like yung fluorite, halite, and calcite. Sabi nga natin kanina, kapag walang cleavage ang isang mineral, ang result niya is the fracture. So the way a substance breaks were not controlled by cleavage. So minerals with no cleavage generally break with regular fracture. So if minerals break with concurved fracture surface, it is called conchoidal fracture. And this is seen in glass, the igneous rock, obsidian, and quartz. For number 6, we have specific gravity. So it is the density of a mineral. So the density is equal to the mass of an object over the volume. So So the specific gravity is the ratio of the mass of an object to the mass of an equal volume of water. So the density of pure water is equal to 1 gram over ml. So if the density of the object is less than 1 or lighter than water, so it will float, or substance will float. And if the density of the object is greater than 1 or heavier than water, so the substance will sink. So we have here examples like quartz. So quartz has a specific gravity of 2.65 grams over ml. So galena, we have 7.5 grams. And for gold, it is equal to 19.3 grams over ml. So we have number 7 for crystal form or habit. So crystal form is a solid crystalline object that is bounded by a set of flat faces that are related to one another by symmetry. So when we say habit, it is the characteristic external shape of an individual crystal or crystal group. For number 8, we have the tenacity. So when we say tenacity, it is the measure of a mineral's cohesiveness or toughness. So we have here different terms in tenacity. So first one is the brittleness. So when we say brittleness, it breaks or powders easily, or the mineral turns into powder. So the best example is the pyrite. So the mineral pyrite or iron pyrite is also known as fool's gold. So nakikita naman natin sa picture, para siyang gold. Because it has metallic luster and pale brass yellow hue, give it a superficial resemblance to gold. So it is much lighter but harder than gold. So it is brittle and will break rather than bend as gold does. Second is malleability. So in malleability, the substance can be hammered into thin plates or sheets. So we have here gold. So gold is one of the densest of all metals. So it is also the soft and most malleable of the elements. So just an ounce of gold could be pounded into a thin sheet that could be spread over an area of 1,000 square feet. So another term for tenacity is the ductility. So when we say ductility, so a mineral can be stretched into wire or can be drawn into wire. So we have here copper. So copper can be formed and stretched into complex and intricate surfaces without breaking. So the very small diameter wires, which transmits power in cars, computers, televisions, lighting, and mobile phones, only exist because of the highly ductility and malleability of copper. We also have flexible and elastic. So in this, minerals are bent and they bring back to their original position. So the minerals bends and resumes its original position or shape when pressure is released. So our best example for flexible and elastic is the biotite. So biotite is also called as black mica, a silicate mineral in the common mica group. And last is sectility. So it is the ability of minerals to be sliced by a knife, or it can be cut or shaped with a knife. So best example for sectility is the gypsum. So gypsum is the one of example, and it is a soft sulfate mineral composed of calcium sulfate dihydrate, and it is used in manufacturing wallboard, cement, and the likes. So for number 9, so we have here other special properties. So that includes taste, odor, striation, magnetism, double refraction, X-ray fingerprints, and chemical tests. So the following are just an additional test used in identifying the physical properties of minerals. So first one is taste. So few minerals have a characteristic taste. So just like halite. So halite tastes like salt. But in taste, so hindi siya applicable sa lahat ng minerals because hindi naman lahat ng minerals ay may lasa. So next one is odor. Few minerals have characteristic odor. So just like clay minerals, it has earthy smell.